Hi, welcome to the Calculus 1 lecture series. And we are starting a new unit from this video. We're going to start in unit number 3. We talk about the applications of the differentiations. So the first lecture, we're going to talk about how to find the maximum value and the minimum values and what is their definitions, from your function by using the calculus concept here. Okay, so now let's go ahead and go to our lecture notes here. Okay, so before we start to, this unit, this lecture, let's take a look at some few definitions here. So the first thing is here, we want to talk about what is the absolute max and what is the absolute mean. And then we're going to see, what is the extreme value theory, how do we find the absolute values, the absolute max value or absolute mean values here, right? Okay, so what is the absolute max here? So we said let f be a function, right? So let f be a function in the domain D. Okay, so we said f has an absolute max at C at some x equal to C. That means f of the C is the maximum values, right? Okay, so that means, what that means? That means f of x, because it's the maximum value is less than equal to the C for all the x in the domain, okay? So the same way, in here, that means if you have some domains here, right? So like if here, and then this will be your low, this will be your absolute max, right? Because all this function, this is the largest one. Okay, so now let's take a look at absolute mean. So this is that same things. Let f be a function in the domain B. Then we say f has an absolute mean. What's that mean? At x equal to c, that means f of the c is the minimum values, right? Okay, so that means f of x greater than f of the c for all the x belong to D, right? So if you have a function like this, right? So if this quadratic, then this value will be what? This value will be the absolute minimum value because all the other values are greater than here. Okay, so in here, one thing here, be careful, do not confuse with this absolute. It's not the absolute value we talk about, it's always turned positive. No, this is the absolute biggest one, absolute the smallest one. Okay, so now we're going to introduce one very important theory we call the extreme value theory. So what is extreme value theory? So they will tell you, so let's say a functions, okay, the extreme value. So the extreme values must always exist for a continuous function whose domain is a closed interval. All right, so the key things here, we need to be careful here, right? So this function has to be a continuous function. And also the domain has to be in a closed domain here. So it's a kind of makes sense, right? So if it's not continuous, so you don't know where is that. So if this is a continuous, right? So it's in between here and here, right? So because it's continuous, the largest number and the smallest number must exist here. Okay, so those are the two Very, very important key part for the extreme value theory. Has to be continuous, has to be close. Okay, so now let's take a look at some problems here, right? So like a problem number 1, so let's say that how many extreme values for each of the 3 graphs below? Okay, let's take a look at here. This is my domain, right? So how many extreme values here? I have this ones here, and I have this ones here, right? So this is absolute max value. This is absolute minimum value, correct for here. So C is here. This is absolute what? Absolute max. And this one's absolute means, right? So ABS mean. Okay, let's take a look at this one's here. Okay, this function is very interesting, right? So this is my domain, see here, from here to here. And now at this end, the domains here is, so whatever is this values here, right? So for this province here, we really have what? We really have one extreme value. So this is my extreme value. So this is my absolute what? This is my absolute mean. And then you might ask, what happened to here? What happened to this one? Is this is the maxima value? No, because this one's here, right? So if you say these numbers here, you know, when my function getting closer and closer, right? So it will getting closer and closer to this, you know, to this line. So if I say this is A, so it's going to getting closer and closer. But when the function equal to A, here is my function value. So this could go very, very tall, right? So that's why I don't know how high this one can go. So I don't have absolute maximum for this one here. You get that? Okay. Now let's take a look at this one. This one is a very interesting one here. So this one's here, you see these functions, right? So this is in a close, you know, like in this closed intervals here, right? Okay, but the problem is not continuous. So you take a look at this one, you say, oh, here, this one is absolute. You said, hey, this one is absolute mean. Is this one is absolute mean? No, because, you know, like if you take a look, when you go, you get closer to here, right? So you will be so close to whatever this value is, but I don't know how close it is, right? So when the f of this number, this is a function value, this one is in between here. Also the same ones here, you know, when you're going to closer and closer, right? So your function going to get closer and closer to this value, but I don't know how close it will be. So for this ones here is no absolute max and no absolute means here, right? So that's why this definition, close interval, is very important, right? Because in here, when you go in here, right? So because this is empty, so when you go closer and closer to this point, you're going to get closer and closer and closer, but you don't know how close it. So you don't know what exactly, you know, what is the number you will reach, right? But then when you set the end point, then the value drop back to here. And this value is not the largest one or the smallest ones here. Okay, so this graph is, you know, this problem is really is a pretty good problem. It's kind of give you a pretty good concept here, right? Okay, so now let's take a look at number 2 here. The number 2, let's tell you, if x, f of x greater than f of c for all the x in domain. So if it's everything is greater than, so what I have absolute what? I have absolute minimum, right? Because everything is greater than. Okay, so now number 3 is here. They say where is the, so here, this one's here, this should be not the braces, this should be bracket. Okay, so it's closed. Okay, so this one is said, where does the absolute minimum value occurs for this function with this domains here? Okay, so for here, let's try to do a graph first, right? So this is 1, 2, this is 1, 2. So this is a quadratic because this is negative, so open downward. So when x equal to 0, you have nice here, right? So when x equal to 2, and so what do you have here? So you have when x equal to 1, you have 8, 2, you have a 5 here, right? So in here, this is your functions here. Right, so here this is 5, right? So like in here, right, because my boundaries here, my domains here, this is a 2 and this is negative 2. So when you put the 2 back there, so this you get a 5 here. So from here, so let's say, where does the absolute minimum value exist? Does it exist? Yes, right? Because this is a closed interval. So I know when you go down close to here, you're going to reach here, right? So we say yes here, right? So we said the absolute minima exist, and absolute minima equal to what? Equal to 5. Where exist? At x equal to 2 and x equal to negative 2. So you can have one place, all right, to decide is the extreme, for the absolute max or absolute means here. Okay, let's take a look at this one here. This one is say, does the extreme value guarantee the extreme value exists for the function graph? Well, from this domain, can I do that? I say no. Why? Because why? Because this function violates the extreme value theory conditions, right? So what is the condition? The function has to be continuous, right? So this function is not continuous, obvious, right? So be obvious is not continuous. So I cannot use the extreme value to see the, it's the function has an absolute max or absolute mean. But this function's absolute max does exist. Absolute max exists and absolute mean exists. Why? Because in here, this is my absolute max. So this is the largest point. And this is my absolute mean. So it does exist, okay? And it's just by not using extreme value series, right? So I cannot use in the extreme value series because it's a violate one condition because f is not continuous. Remember, extreme value series has to be continuous in a closed interval. And so I cannot apply it, but still exist, right? So it doesn't mean if not apply, you not exist. It's here, right? So it exists, but not apply extreme values, right? But it's not applied extreme values, okay? So that is, we need to be very, very careful here, okay? Now let's take a look at the next one. We still talk about the max and the mean, and now we are talking about local, all right? So the local max and the local mean. We also sometimes we have a different term, the local max and the local mean. Sometimes we call it is relative max, and this is relative means here. Okay, so now let's take a look at what is the definitions here. So we say the function f, right, has a local max. What's that mean? At C. Okay, so at and f of the c is greater than equal to f of x. It's very similar, like we define absolute max for all the x near C. Okay, so here be very careful. So we mean the near C means there is an open interval, perhaps small, open interval, and I that contains, okay, C and X in I, okay? So the very, very key word just here is, we said the function have local max. That means we still define this as FC greater than, right? So here is the, for all the X near C. Near C, that means we're very close to C. So here's another keyword is open intervals here that contain the C and X in there. So what I mean there, right? So like in here, so let's take a look at this graph here. Okay, so if I have some functions here, so if this is my function, I continue going down and up, right? So for this ones here, for this point here, for this point, obviously, this is not the maximum value because this function continues going up. Obviously, this function is not the minimum value because the function continues going down. But I say, you know, if I have an open intervals here, I can have like a, so just around this area, right? It's a very close interval. Hey, in this interval, yeah, this red one is what? Is the largest one. That's what we call it, is relative, right? So compared to its neighbor, yes, the red one is the largest one here, okay? So that's the same definition. You can say the local mean, that will be the f of the C is less than f of X, right? For all the X near C here, right? So the near, that means I'm only looking for a small interval around it. If you look at the whole picture, yeah, it is not the largest one, not the smallest one. But a while ago, when we defined the absolute max, absolute mean, we are looking for overall in the whole domains here, right? So in here, I'm not care about the whole domain. I'm just looking for the open intervals here. All right. So now let's take a look here, right? Okay, so we want to see here. So let's say find the extrema for the, okay, so this is still, I guess, the find extrema for the f of x square root of x at 1 9 here. So this is one, this is still, I think it's belong to the absolute max and absolute mean. So for the f of x equal to 1 and 9, so when x equal to 1, I have 1s here, right? So it's 1 and 9. So when x equal to 9, I have, so this is 1, so this is 3, so I have here. So this is my functions, right? So this is my function. So because this is a continuous and inside this interval, so I know the absolute what? Absolute minima is equal to what at 1 when x equal to 1, and absolute, okay, so then absolute maxima is at x equal to is 3, right? So at x equal to 9 here. Okay, so now let's take a look here. This one is very interesting, right? So let's take a look at number 6. Let's say if F has a domain A and B, C is inside here. Okay, so be very careful the notation, right? So this is open intervals here, and my domain is a closed intervals here. So let's say if f has an absolute minima value at C, then we can say that f has a local minima at C. This is true or not? So let's take a look here. Because I have, this is a closed interval A and B. Okay, so let's say that I have a value here. All right, so this is my f of x here. So it says here, it said, hey, I have a absolute, so this number C is here. This is the smallest value, right? So I have a absolute minima. This is also its local minima. We say yes. Why? Because I only care about the small area surrounding here. Then it is yes here. All right. And so I said, and that's why the C has to be inside this interval. So this answer is yes. So how about if you ask me, so for these functions here, for example, for these functions here, right? So the absolute max is at what? At x equal to b, right? So this is my absolute max. So that the local max is in here? No. Why? Because I cannot find the open interval. So because this is the end here, I cannot find the interval on this side, right? So this is, I cannot find the open interval. So the absolute max at the x, but the local max will not be. So that's why in here, this is very, very important. The local max and the local mean, they cannot happen at the boundaries here. You get that? Okay. Okay, so now let's take a look at number 7 here, right? Okay, so the number 7 here, they said, let's try to find the local minima and the local maxima to see in this interval here, right? It's the A and the B here. B is open intervals here. All right, so local are this one, this one, this one, this one, right? So those are the 3 local what? Max. Why? Because I can find a small interval around it. Hey, that one is the largest number. Now let's take a look. Where is my local minima? Oh, here, I have a dip here. I have a dip here. So in here, in here. Do I have in B? No, because this is open, right? And also I cannot find the interval at the end point. So how many here? I have 2 local minimas here. Okay, so now we also like also how about you said how about in here? Do we have a local minima here? No, because this is the end point, right? So the reason why so A is not a local minima. Why? Because A is the end point. So the local max and the local mean cannot happen at the end points here. Okay, so now let's hear the problem number 8. And after we finish this one, let's take a break and then we will continue this lecture on a second set of the videos here. So let's say Sketchup Graph, okay, of f of x is 2x plus 1 over x squared. So let's see here, 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5. Okay, so 1, 2, 3, because I only want to get a 3s, right? So x equal to 1. X is start at 0.5, right? So 0.5, so it's 1. So 0.5 is 5. 1, 2, 3, 4, 5. So it's here. When x equal to 1, 1 is 3. Okay, so this is 1, 2, 3, 4, 5. So this is a 5. And the 1 is equal to 3. So it's going down here. And let's see the 3. 3, 1, 2, 3. So it's something close to the here, right? Okay. And so I have a point here. Okay. So this is my 3 and this is 0.5, right? So this is my domains here. My domain is from 0.05 to the 3s here. Okay, so now for here, I know. So do I have let's take a look at absolute, right? Absolute, so I have an absolute minima at where? At 1s, right? At x equal to 1. Do I have an absolute max? Oh, yes, I have an absolute max because at the end point in the 3, right? So I have an absolute max and x equal to 3s, right? So this maximum value is kind of like is 6.11 something, right? Okay. So I do have the absolute max and the absolute mean. So now the local, so where is the only local one? I only have this ones, right? You can find it here. So the local mean is x equal to 1, correct? And do I have a local max? No, right? So I don't have a local max here, right? So the no local max. Why? Because this point is at the end point, and the local max and the local mean will not happen in the, the end point, right? So in here, that's why. And also, how about the 0.5? Is this one is local max? No, because it's at the end points here. Okay, all right, that's it. That is the first part of this lecture, and we're going to have a second video to finish the remaining part of this lecture series. And be very careful, right? So the key things to take away is absolute max, absolute means, right? If you want to apply the extreme value theory, it will always occur for continuous function in closed intervals here. And doesn't mean if you fail the extreme value theory, then the absolute max, absolute mean does not exist. It doesn't mean that. Okay, then the other things here is the local max and the local mean. Be very careful. Local max and the local mean will not happen at the end point, right? Or will not happen at the boundaries of your domains here. Okay, that's it. And looking forward to talk to you about our next video. It's a very important topic. We're going to talk about the critical values here. All right, that's it. Okay, bye.